Hello, welcome students. Welcome to this wonderful channel Unacademy JEE English, and this is me Umesh Garg. Today we will be doing a sprint on definite integration. Okay students, it will be a very amazing session. We will do problems on the odd function, even function, and the graphical interpretation of definite integration. We will do problems on these type of ideas. So it will be a very wonderful session. So let's start with it. This is me Umesh Garg. I have 5+ years of teaching experience. I have done my BTech from NIT Kurukshetra and I have also qualified JEE. So just subscribe to the channel Unacademy JEE so that you can have these beautiful lectures on your fingertips and you can learn from them in the infinite amount. And do share this video with the tag hashtag JEE Daily so that it reaches to the maximum people and they can get benefit from it. And student, this is the interface that we have created, tinyurl.com/JEE mobile. You just type this on your browser and this interface will pop up. Here we have sorted all the lectures that were already available on YouTube. If you click on the link, lecture will start, and if you click on the link of PDF will get downloaded. But you must remember that the lectures here are in Hindi. The lectures here are in Hindi. Very good students, very good. So now UMESHLIVE is my referral code for Unacademy subscription. If you use this referral code, you will get a 10% of discount on your subscription value. Got my point? But what I want to draw your attention is that there is a recent price drop in the 2-year plan. Now the 2-year plan can be availed at the price of 32,400. So let's see who else has joined us. Very good students, welcome everyone, welcome to the class. So let's start with it. This is the first question. Integral 0 to infinity twice of e raised to the power minus x greatest integer dx. This is the greatest integer. We need to integrate this integral and options are given to me this as follows. So a greatest integer breaks its definition at the integers. It will be 1 from 1 to 2, close 1 to open 2, and it will be 2 from close 2 to open 3. So we must redefine this function in the given specific domain to find its integral. Getting my point? Very good. So let's start with it. This integral, let us suppose this is I. It is written as 0 to infinity 2 upon e to the power x greatest integer dx. This I need to solve. Got my point? Now as x starts from 0, so e to the power 0 is equal to 1. Therefore this greatest integer has initial value 2. 2 upon 1, it will be nearly 2. Greatest integer value will be 1 because it will be greater than 1. So how should I break that? This greatest integer, when it will become 1, this fraction, when it will become 1, the greatest integer will break its definition. Got my point? Very good. So let's start with it. Solve for 2 upon e ki power x is equal to 1. So e ki power x becomes 2 and x becomes ln 2. Got my point? So from this integral can be written as 0 to ln 2. In this interval, this value, this fraction 2 upon e to the power x, it will be varying from 2 upon 2, 2 upon 1 to 2 upon 2. Basically it will varying from 1 to 2. So greatest integer will come out to be 1 plus this integral remaining after that ln 2 to infinity, the whole fraction will become 0. So it will be 0 dx. Got my point? Very good students, very good. So let's start with solving it. This integral will be this will be 0 to ln 2 1 dx. Getting my point now? Very easy question. Plus this will be 0 and this integral will solve down to ln 2. So because integral of 1 will be x, and if you put the limits, the value of integral will come out to be ln 2. Got my point? Very good. Therefore the answer will be B for Bombay. Getting my point? Very good students, very good. So let's start with the next question. This is a wonderful question, very amazing question. 0 to infinity e to the power minus x square dx is given to me as root pi by 2. As all of us know that e to the power minus x square or e to the power x square, these type of functions, they are generally not integratable, that we have studied. So I will use this integral to find the value of this integral. Getting my point? Very good. So let's try. We are given I is equal to 0 to infinity e to the power minus ax square. This is given na, e to the power minus x square So what I am doing, a to the power, I am writing it as minus root ax whole square. I am taking this a into the square so that it becomes of the format like this. Getting my point? Very good. So I am writing it as root of ax whole square into dx. This is the manipulation that I did. Now what to do? Just apply the substitution. Root of a into x is equal to t. Just apply this substitution. Root of a into x is equal to t. So differentiation, I am differentiating it with respect to x. You must remember, some children, some students just write it 1 by 2 root a. No, I am differentiating with respect to x. So root a will remain constant. Therefore root a dx will become dt. So dx will be dt upon root a. So this will become, now since x goes to 0, t goes to 0, x goes to infinity, t goes to infinity. Got my point? So it will be 0 to infinity. Very good. And it will become minus t square, and dx will become dt upon root a. It will become dt, and 1 upon root a, it will come outside of integral because it is constant. 1 upon root a, it is constant, so it will come out of integral 1 upon root a. Now this integral that I have written in the green color, this is similar to this integral, actually equal to this integral. Only change of variable is there, which does not affect the value of integral. Therefore this value will come out to be root pi by 2. So the final answer of the integral will be root pi divided by 2 upon root a. Getting my point? So this can be written as root of, yes Anand Dikshit, obviously, yes, thank you beta, thank you Anand. Got my point? This was very simple question but very important one. Very good students, let's try the next question. This is a very fundamental question. F of pi equal to 2, 0 to pi fx plus f double dash x sin x dx is given to me as 5, and I need to find the value of f of 0. Okay, so just multiply the sin x into the integral and separate the integral. First integral will become fx into sin x, plus second integral will become f double dash x into sin x. Then we will start solving. Very good, very good. Then we will start solving. So this integral, it can be written as 0 to pi f of x into sin of x dx, f of x into sin of x dx, plus next will be 0 to pi f double dash of x into sin of x dx. I am rewriting these as this. Now their summation is given to me as 5, that I will use in the further steps. Hi beta Kirti, hi Anand and Giryan. Actually I think the chat is bit delayed, so I'll answer correspondingly. Till then we will be solving question. So now I am solving these integrals by the Eilert rule. Okay, sorry, got my point? So I am applying Eilert rule, and while applying Eilert rule, I am thinking that I do not know function fx, therefore I will not integrate fx anyhow. So this will be always my first function and this will be my second function. Getting my point? So I am applying Eilert rule on this integral, and I am writing the situation that will come out to be first function integral of second function will be minus cos x. Okay, minus integral of derivative of first function will be f dash x, and integral of second function will be minus cos x. Got my point? So derivative of first function will be f dash x, and integral of second function will be minus cos x. So minus minus plus. So this is the first value or equation after the application of Eilert rule on this integral. It will come. That is okay. Now apply the Eilert rule similarly on the second equation. On this equation, I want to integrate this function. So this will be first function and this will be second function, because I want to integrate f double dash x. Getting my point? So first function integral of second function. Okay ji. So first function integral of second function will come out to be f dash x. Getting my point? Minus integral of derivative of first function will be how much? Derivative of sin x will be cos x, and integral of second function will be f dash x. Integral of f double dash x is f dash x. Hello, Suman. Hello. Getting my point? So these equations we will arrive after applying Euler rule. Obviously, limit of integral is 0 to pi. That is okay. So if I observe that this f dash of cos x and this f dash x cos x, they cancel out each other. So I cancel them. These two terms cancel out each other. So just cancel them. Got my point? So what will remain? The remaining value will be, remaining expression will be minus of fx, this one, into cos x. Got my point? This one will remain, plus sine of x into f dash x. Here you have to put the limits 0 to pi, and this value is given to me as 5. This integral is given to me as 5. That is okay. Now just put the values and get the answer. When you put the value pi, it will become f of pi, and cos pi minus 1, minus positive, so it will become f of pi, plus it will be sin pi into f dash pi, sin pi 0, so f dash pi becomes irrelevant. Got it? Minus, if you put 0, so cos 0 is 1, and it will become minus f of 0. That is okay with everyone, na? And sin 0 is 0. This value is given to me as 5. I hope everybody have understood the situation, that what is in the question. Very good. Now 0 is irrelevant. This becomes f of pi plus f of 0 equal to 5. Now f of pi is given to me as how much? 2. So f of pi is 2. Then f of 0 will come out to be 5 minus 2, 3. Therefore the answer will come out to be B for Bombay. Got my answer? Yes or no? Just tell me that. Have you got the answer or not? Very good. Wonderful question. Let's try the next question. Yeah, this is a question based on odd even function. You can solve it by that idea only. I will solve it by king property, as I have discussed in the previous session, that you can replace x by a plus b minus x. So therefore it becomes simple standard question of king property. That is okay with everyone. Now I am applying a simple trigonometric formula here. Cos of 3 pi plus x is cos x, and even the whole even power is there, so it can be written as cos square x. Getting my point? Very good. So let's try with the integral. I will be written as minus 3 pi by 2 to minus pi by 2, and it can be written as x plus pi whole cube, okay, and cos square x dx. This I am writing as I. Now just apply the king property. I'll write it as apply king property. What is king property? That I have discussed in the last session. X can be replaced as a plus b minus x. This is the essence of king property. Got my point? Very good, students. So if you apply it, the new I that will come out, the sum of limits is minus 3 pi by 2 minus pi by 2. It is minus 2 pi. Sum of the limits is minus 2 pi. Very easy. So minus 3 pi by 2 to minus pi by 2, the limits remain same, and in place of x I will write a plus b minus x. A plus b is minus 2 pi, so I will write minus 2 pi minus x plus pi, so it will become minus pi minus x whole cube. Getting my point? Very good. And this will become cos minus pi minus x. Minus becomes irrelevant in cos, and since there is even power, so I am not very much concerned about whether it will be cos x or minus cos x, as I know cos pi plus x is minus cos x. Even power will make it positive. So this becomes the new integral I. Got my point? Very good, students, very good. Now after this, just add these two integrals. There is very standard approach. Once you apply the king property, then you have to add the two new integrals, okay? So it will form 2y is equal to minus 3 pi by 2 to minus pi by 2. Got my point? Yes or no? So minus 3 pi by 2 to minus pi by 2, and once you add them, these two brackets will cancel out each other, because this is x plus pi whole cube, and if you take out minus common, it will be x plus pi whole cube. So they will cancel out each other, and it will become cos square x plus cos square x twice of cos square x dx. So this is the final equation that we will arrive after adding these two equations. Okay, very good, very good. So this will be cos square x. Now 2 and 2 will cancel out each other. This is a very simple integral, you can solve it very easily. So minus 3 pi by 2 to minus pi by 2, and cos square x can be written as 1 plus 2x, sorry 1 plus cos 2x upon 2 dx. Now this integral, half is outside of integral of 1 is x. This can be written as, you know, let me write it. I can be written as 1 by 2 and x plus sine of 2x upon 2. It is going from minus 3 pi by 2 to minus pi by 2. That is the value of standard integral. Very good, student, very good. Got my point? So now once you apply the limits, minus pi by 2 minus 3 pi by 2, it will come out pi upon 2, pi will be pi by 2, and if you put this value in the argument of sine, it will become sine pi, that is 0. It will become sine 3 pi, that is also 0. So I will come out to be pi by 2. That will be the answer. Got my point? So pi by 2 is in the option B for Bombay will be the answer. Good evening, beta Falak. Good evening everyone, good evening. Very good. Let's try the next question. Very simple question. Again, you know, it is a question based on the property of king. I'm writing it as I is equal to 0 to pi by 2 dx upon 1 plus tan cube x. Got my point? So I am applying the king property here. Once you apply the king property, x can be replaced by sum of limits pi by 2 minus x. So apply king property and rewrite the value of I. This can be written as I is equal to 0 to pi by 2. I am applying king property here. That should be remembered. Got it? So this can be written as dx upon 1 plus tan pi by 2 minus x will become cot x. Got my point? So it will become cot cube of x. That is okay. Now this I can be again written as 0 to pi by 2, and cot x can be written as 1 upon tan x. So it will be written as tan cube of x upon 1 plus tan cube of x dx. So this is the, you know, final integral after applying the king property. Good evening status, good evening everyone. Okay, now just apply these two integrals. You know, I have told you that king property has a standard approach to solve the question. First apply the king property and then add the integrals. Got my point? So after finding calculating the I, just add them. So it will become twice of I equal to 0 to pi by 2, and it will become 1 plus tan cube x upon 1 plus tan cube x. Getting my point? Very good. 1 plus tan cube x upon 1 plus tan cube x dx. So it will cancel out each other. It will become 1. So I will become pi by 2 upon 2. It will become pi by 4. Therefore, the answer that will come out to be will be D. Very good, Radha. Very good, Sumit. Very good. No, answer will be D for Delhi. It is 2I, na? Falak beta. It is 2I. Got my point? Again, very good. Next question. Let's try. Very fundamental question. You know, sine of x minus box of x and d of x minus box of x. This is box of x. It should be written in the question. This symbol it represents greatest integer function. So x minus box of x, let me write this integral as I. It can be written as 0 to pi by 4 sine of fractional part of x. This is the symbol, you know, into में d of fractional part of x. This is the integral that we need to solve. That is okay. Now since x is going from 0 to pi by 4, pi by 4 is nearly 0.75, so it is going from 0 to 0.75, so it is the principal domain of fractional part function. So in that domain the fractional part will become x only. So this integral, it can be rewritten as I equal to 0 to pi by 4 sine of x dx. That is okay with everyone, that fractional part x will become simple x. Very good. B is the right answer. Himank, status lover. Very good student. Very good. Now, to solve this integral, it is very simple. Just integrate the symbol. I will be 0 from where to where? 0 to pi by 4. 0 to pi by 4 sine of x dx. Got my point, na? Very easy. Very easy. Integral of sine x is minus cos x. Just put the limits to get the answer. So it will come out to be 1 minus 1 by root 2. I hope most of you have got it. It was a very simple question, but very interesting one. बहुत दिया चलिए जी, very good. Next question. So this is also a very wonderful question. You can solve it by the substitution also, but I'll try to solve it by the king property. That is because whenever the sum of limits is 0 na, I happen to I have a very soft corner for king property. I will use it anyhow. So let me write this integral as I is equal to minus 1 to 1. It will be x to the power 4 upon 1 plus x to the power 7 dx. So this is the integral that we need to solve, and sum of limits equal to 0. Minus 1 plus 1 sum of limits is 0. Now so I am applying king property. Apply king property to get the new integral. X can be replaced by minus of x because sum of limits is 0. So this I, it will be written like this: minus 1 to 1 minus x to the power even 4, it will be same, x to the power 4 dx, and 1 plus it will become minus x to the power 7. Yes or no? Got my point? Yes or no? Very good, very good. So yes, C is the right answer. Who has given it? Himank. Very good student. C is the right answer. Now, e to the power minus x upon 7. This will be written as 1 upon e x to the power 7. Take LCM, and this new I, it will be written something like minus 1 to 1, and it will be x to the power 4 into e into the x to the power 7 upon 1 plus e into x to the power 7. After taking LCM, the denominator will go in the numerator. Very good. C is the right answer, students. Very good. Very, very good. Now apply these, add in these two integrals. As I have told you, once you apply the king property, the second step will be add the two final integrals. Very good. Just to add the two integrals, it will become 2i minus 1 to 1. Get my point? Now the denominator will become same in the LCM, so it will be 1 plus e x to the power 7, and x to the power 4 will be common, and what will be the remaining factor? The remaining factor will be, from here it will come 1, and from here it will come e x to the power 7. So it will come 1 plus e x to the power 7. So they will cancel out each other. Yes or no? Very good. So now 2i is equal to minus 1 to 1 x to the power 4 dx. Now this is a even function graph, even function. So its integral from minus a to a can be written as from 0 to a twice. Got my point? So this integral will be 0 to twice of 0 to 1 x to the power 4 dx. Now 2 and 2 cancel. I will be 1 upon 5 x to the power 5. It will be 0 to 1. So I will come out to be 1 upon 5. Therefore the answer will come out to be C for Calcutta. Very simple question, but very amazing solution. Yes or no? Very good, students. Let's try the next question. Yes, this is also a wonderful question. Wonderful way to solve it. E to the power 2x minus greatest integral of 2x minus d derivative integral is x minus box of x. That is fractional part of x. Got it? Now just rewrite this equation in the form of fractional x. This given I that we need to calculate, this will be written as 0 to 1, that is the limit of integral e to the power fractional part of 2x, and integrate it with the element fractional part of x. This is the integral that we need to solve. Got my point? Very good, students, very good. So the fractional part changes its definition at integers, so this will become integer at 1. So basically 0 to 1 is the principal domain for fractional part of x, so it will not affect any our integral. Now we need to think about this twice of x fractional part. This fractional part, the domain will go from 0 to 2, so we will have to break the integral from 0 to half and half to 1. Why? Because at half this becomes 1 and fractional part changes its definition from at integers. That is okay. So I will break this integral as I will be equal to 0 to half, and that becomes the principal domain for twice of x fractional part. So it will open as 2x d of x. It will also open as x, plus this will be the second integral half to 1, and it will be written as fractional part of 2x. It will be e to the power 2x minus 1 and integral with respect to x. That is the solution. No, C is the wrong answer. Status lover, C is the wrong answer. Got my point? Very good. Now just integrate it and get the answer. So it will be e to the power 2x upon 2 from 0 to half, plus, and it will be e to the power 2x minus 1 upon half from half to 1. Getting my point? Yes or no? So the value of the integrals that will come out to be, just put half, it will be e to the power 1, so e minus 1 by 2, plus take half outside and it will become, just put 1, so e to the power 1 minus, just put half, so it will be 1 by 2. Yes or no? Sorry, 1. That will be the answer. Yes or no? Getting my point? Just put half, e to the power 1 minus 1, 0. Yes, very good. Right answer. So this will be double of e to the power, so e minus 1 will be the answer. So that is not in the any case, so answer will come out to be D for Delhi. Got my point? Very good, very good. No, Shreyash, no. Student, answer will be D for Delhi. This one, D for Delhi. Got my point? Wonderful question. How to, how to simplify the fractional part in integration. That becomes a headache for the students. Very good, students. Let's try with the next question. Yeah, this is also a wonderful question. If fx is a continuous function and attains only rational values in -3 to 3, and its greatest value in this interval is 5. So, for this question, you need to understand only one thing. That is, let us suppose this is point 1, 1, any point, and let us suppose this is point 1, 2, or 2, 2 for that matter. That is okay. Now, in between these 2 points, if somebody asks you that in between these 2 points, how many rational numbers are there? You will say infinite. Got my point? And if somebody asks you how many irrational numbers are there, you will say infinite, because if you go from 1 to 2 in only think of x, not y, then there are infinite values which can be rational and there are infinite values which can be irrational. So got my point? Now this question says that a function takes only rational values. It takes only rational values in the interval -3 to 3. Okay, sir. And its greatest value is 5. So let me draw the graph of this function. It will become very easy for you. So let us suppose these are my coordinate axis, y axis, x axis, and let us suppose this is my interval from -3 to 3. I need to think, and this function has the greatest value. Yes, D is the correct option. Very good. This function has the greatest value 5. Let us suppose it came at the x somewhere here. I am not concerned about whether the maxima is attained at 1, 2, 3, anywhere it can be achieved. Now if suppose at any other input, let us suppose at x is equal to 3, if function comes here, then since this function is continuous, the question has given us that it is continuous function, so the function have to go like this only. Therefore from to go from this point to this point, this function will attain infinite irrational values, as I have discussed with you in the earlier session. Got my point? That if a point moves from this point to this point, it will cross infinite points that will have irrational coordinates. That is okay. Therefore for a function to have only rational values, it means that this function will remain constant, which is y equal to 5. It will remain at this value only, because this value is rational and I have to take only rational values, so I cannot move even an inch from this point. If I move from 5 to 5.1, I will take infinite rational values in the meanwhile. Therefore from this statement I conclude that this is a constant function, which is fx is equal to 5. So from here we can conclude that fx is a constant function 5. Got my point? So this integral is very simple now. So we need to solve minus 3 to 3, fx is 5 dx. So take 5 outside, it will be 5 into 6, 30. Therefore the answer that will come out to be D for Delhi. Got my point? Very good students, wonderful, wonderful students. So this is the next question, very amazing question. You know, in this element of integration has been changed to cos x. Now we have to integrate with respect to cos x. That is the question. That is the problem that we need to address from this question. Rest is very simple. So 1 by root 2 1 quote of d of cos x. So first of all of you must understand that one second, that derivative of cos x with respect to x is given to us as minus of sin x. This is a very fundamental situation that I am using. Yes, Shreyash, we cannot say every point is maximum, because for maxima value from the left neighborhood and value from the right neighborhood should be lower. You know, my value should be greater than my neighborhood for me to be a maxima. Okay? Yeah, Shreyas, that is also the same thing. What I am saying, that d of cos x upon d of x is equal to minus of sin x. From here I can conclude that d of cos x will be equal to minus of sin x dx. So I can convert this integral into a simple integral. Simple integral means integral with the element dx. So now the question is solved. Just apply this substitution. You know, it will be 1 by root 2. That is also the trick, that this integral will be cot x will be written as cos of x upon sin of x, and it will be minus sin of x dx. But you must remember that this in this integral, since these are the limits of these limits are of cos x, these are the limits of cos x, these are not the limit of x. So if cos x goes 1 by root 2, then if cos x goes 1 by root 2, then x will go to pi by 4. So in this integral the limits will change from it will go from pi by 4 to pi by 3. This concept needs to be understood very properly, that in this integral the limits of integral, they are limits of cos x, that cos x is going from 1 by root 2 to 1 by 2. Now since I have changed this integral into x, so I need to find the limit of x also. Got my point? Now so accordingly I change the value of x, they will go from pi by 4 to pi by 3. So sin x cancel out, minus outside integral of cos x is sin x, and value of the integrals are from pi by 4 to pi by 3. Got my point? Yes or no? Now just apply the limits. It will come out to be, you know, minus outside it will be root 3 by 2 and minus 1 by root 2. These are the values. Take the negative inside, it will be 1 by root 2 minus root 3 by 2. Now take the LCM as 2. Root 2 and 2, we can take LCM as 2. It is not the LCM, but for simply calculating, I will take 2. It will be root 2 minus root 3. Getting my point? Therefore, the value of integral will be root 2 minus root 3 upon 2. So answer will come out to be B for Bombay. Very wonderful question, amazing question. And you have to learn, you should understand that the most important thing in this question is to change the limits accordingly. I hope everything must have been very amazing, and you have understood all the ideas. Very good, students, very good. So this was our session today. I hope you must have enjoyed all the questions, the very fundamental questions of integral, but very tricky one. All of these questions are important, so you should revise these questions. Okay, and if you have any doubt in these questions, or for that matter in any other question, you can ask me on the special classes, or on the platform also, comment section. So this is our Instagram handle at Unacademy JEE official. Just follow this page to get the notification about the IIT JEE updates. And this is our Telegram app. Telegram app, you should install it and just type in your browser tinyurl.com/JEE-live-chat and join this group. A lot of wonderful students have joined this, and you will benefit a lot from this group. Now let's talk about Unacademy subscription. Unacademy is the best platform in India to prepare for IIT JEE students, and there are some features which make it the best. The first feature is live classes. During live class, your focus and concentration becomes a bit higher, so you will learn very fast and very easily from the live classes. You can interact with the educator. Obviously, if you missed any step, or you didn't understand any concept, you can easily rectify that problem on the situation only. Okay, and live classes, live polls and leaderboard, you will get this option also. From this option, you can easily improve your speed and accuracy. That will help you a lot in cracking your exam IIT JEE. We offer you test series of India level, where you can compete and check that where do you stand in that competition. And live doubt clearing session are also there, student, that helps you clear your doubts, whether it is of theory or numerical. You can easily approach your teacher, because they are dedicated doubt clearing session that will help you improve your concepts of the subject. And this is our platform. 60+ educators are already there. Once you subscribe to the platform, you can watch any educator's video. There is no constraint on that. And this is how a plus class looks like. You can upload your photo of your doubt, and discussion will start, and you can learn infinite from this. Okay, and now let's talk about how to join Unacademy. Very simple. Just install the app, make your profile, set your goals to IIT JEE, and click on the get subscription button. Once you click on it, this window will pop up. Here, students, we have written the plans 1 month, 3 months, 6 months, 1 year, 2 year. So you should go for long time plans, because if you join or stay in connection with the faculty for more time, you will learn more, you will understand the concepts by the time. And obviously the long term plans are financially very, very feasible. And I want to draw your attention towards recent drop in the price of 2-year plan. It has been changed to 32,400. Now it can be availed at this price, which is very much convenient for all the students. And if you use my referral code UMESHLIVE, you will get a discount of 10% on your Unacademy subscription. Very good, students, very good. Yeah, Shresh, we will do something like this. As all of students are asking for it, we will think about it for sure. Okay, so just subscribe to the Unacademy JEE English. You know, it will be a lot of wonderful lectures will be there for you, so that you can understand the concepts and apply them for your understanding. And click on the bell icon to get the notification. Do share this video with the tag #JEE daily, so that it reaches to the maximum number of people. And students, the link for the PDF corresponding to this lecture will be in the description box. Hello beta Subhash, hello. Yeah, and these are our YouTube channels: Unacademy NEET, Unacademy JEE, Unacademy Foundation. So let's crack it, guys. Let's crack it. Thank you very much. And again, yeah, in the next session we will be doing a sprint on area under the curve. So you should revise the concepts that will be used in that session, so that in that sense the session becomes more interesting and enthusiastic, and you will learn a lot more if you come up with some homework and preparation. That is okay. So thank you very much, students. See you in the next session. Thank you.